Right, so here is a visual representation of the algorithm, which can be useful. So if you are presented with this limit, the first thing you want to do is to evaluate the expression, in this case we're naming that expression f, plug at x equals c, because that's the limit value. So we go ahead and evaluate f at x equals c, and then we are going to then check and see if this is defined, right? So this is where we're starting right here. Well, sorry, we're starting right here. So we move to evaluating f of c. This is step number 1. And then here we're going to do a check. This is a question. Is it defined? If it is defined, okay, then the limit exists and equals that value. But that, again, this algorithm's only true if it is working with the elementary functions that we talked about. If it's anything like a piecewise function or a function that you may have never seen or something that has a non-trivial definition, then this is not necessarily true. And an example was in the previous video, we took a look at the floor function. If we do the limit as x goes to 2, this thing spits out 2, but clearly the limit is not does not exist at that location. And that's because the floor function here is actually a piecewise defined function. Okay, but assuming that we're working with an elementary function or the functions that we talked about, rational expressions, logarithm, exponential, or any combination of them, then this will work. So if it is true, then we go ahead and get that answer for the limit. If it's not true, then we go ahead and say, okay, well, what does f of c look like when you plug it in? And we talked about 0 over 0. 0 over 0. So if we get something like 0 over 0, then we are going to simplify and cancel. There are some other indeterminate forms, like infinity over infinity, but simplifying and canceling is not the technique that we're going to use for that. Not usually. It depends on the finer details. This is really supposed to just be an introduction to doing these most basic limits. So if you get 0 over 0, you can go ahead, simplify, and cancel, and then that will make it look like a new limit because you've changed the form. As soon as you get a new form, you want to try again and reevaluate the limit, effectively starting this process over again. You will encounter limits in this class where you start with a limit, get 0 over 0, you do some algebra, and then even after your algebraic manipulations, you still find yourself with 0 over 0, in which case you just go ahead and restart the process. Do more algebra. If we get something like non-zero over 0, we talked about this. This is a vertical asymptote at that location, x equals c, in which case we can immediately conclude that the limit does not exist. But in this class, generally speaking, if we know there's a vertical asymptote, remember that there are 3 options. Our one-sided limits agree and go up, in which case the answer is positive infinity. Maybe our one-sided limits both agree and go downward, in which case the limit is equal to negative infinity. Or the third option is where our one-sided limits go to opposite directions, in which case we can't say positive or negative infinity. We just have to conclude D and E.